All right, this is crazy. Watch this. Under these room lights, this is what liquid oxygen looks like. It's got like a greenish blue color. And look at that. As soon as I walk outside into these different lights, it gets like a more pale steel blue color.
I'm going to try pouring some liquid nitrogen over the poles of this strong magnet to see what happens. Well, that doesn't look like a whole lot happening, except for maybe the magnet getting cold. Well, let's try doing the same thing with some liquid oxygen. Hey, check it out. The liquid oxygen sticks to the magnet.
And it looks like it has a slight blue color, too.
So now let's see the paramagnetism of liquid oxygen in action when I pour the liquid oxygen into a magnetic trap. Whoa, it's like it's orbiting. Now wherever there's a flat plane of the magnetic field is equal in all directions around it. But wherever there's an edge of the magnet, there's a sharp flux in the magnetic field. And so the oxygen can smoothly move through the center of the magnet, but it will basically hit a wall when it hits the edge of the magnet. In the p orbital of oxygen atoms, there's two unpaired electrons. And so when you have paired electrons in the shells of the atoms, those paired electrons cancel out each other's magnetic fields for the most part. And so they're not really magnetic. But if you have unpaired electrons, all of those electrons are going to have the same spin. And so that magnetic field is going to add up. So overall, that atom will have a slight magnetic field to it.
Where chemist Dr. Din carries out a few tests with liquid oxygen. First, let's explain that liquid oxygen is pure oxygen that has been, putting it simply, separated from air by cooling it in a giant refrigerator until it liquefies, and then distilling it. It has a temperature of 300 degrees below zero, which means that when it comes into contact with materials at ordinary temperatures, it boils away. I've noticed that because of its fantastically low temperature, the liquid oxygen has to be kept in a vacuum flask. Now observe the remarkable effect it has on liquid metal mercury. After the boiling process, which gives off a dense fog consisting of cold gas and water vapor, the mercury can be seen again, frozen solid. And we mean solid. It's frightening when you realize oxygen, the stuff we breathe, remember, has such dynamic qualities.